All right, let's get right into it. Every single time you plug something in, your phone, your laptop, anything, a tiny, invisible flip happens. It's a process that is so fundamental, our entire digital world literally depends on it, and yet most of us have never even thought about it.
So it all starts with this kind of weird but simple question. Why is the electricity that powers your entire house completely and utterly useless for the gadgets you use every single day? Well, the answer comes down to two totally different kinds of electrical current.
See, the power coming out of your wall is alternating current, or AC. It's constantly switching direction, surging back and forth 60 times a second. But your electronics, with all their delicate little microchips, they need direct current, or DC. That's a nice, steady, one-way flow. Trying to power your phone with AC is kind of like trying to fill a water bottle from an ocean wave. It's just a chaotic mess.
So engineers needed a way to tame that chaotic AC wave and turn it into smooth DC. And their first try? Well, it was clever, but it was also seriously flawed.
This is what they came up with, a half-wave rectifier. Now, what you really want to look at here is that top graph. The dotted gray line, that's the incoming AC power, with its positive and negative waves. This circuit basically just acts like a bouncer at a club. It lets the positive part of the wave through, but when the negative part comes along, it slams the door shut. It gets you positive current, sure, but look at all that empty space. That's just wasted energy.
And how much waste are we talking about? The absolute best case, maximum theoretical efficiency of this method is a jaw-droppingly low 40.6%. That means almost 60% of the power is just getting thrown away into the void. There had to be a better way.
And thankfully, there was. Instead of just blocking that whole negative half of the wave, what if you could rescue it? What if you could flip it over and make it positive too?
And this is the magic of the full wave rectifier. Just look at that bottom graph. Instead of a flat line where the negative wave used to be, it's been inverted. It's been flipped into another positive pulse. No more empty space, no more dead zones. Now the entire AC signal is being put to work. It's beautiful.
And the numbers just prove it. The efficiency literally doubles to a theoretical maximum of 81.2%. It's such an elegant, almost simple solution to a massive electronics problem.
You know, this quote from our source material just nails the core idea perfectly. It's not about blocking anymore, it's about flipping. It's about redirecting energy instead of just wasting it.
So how does this circuit actually pull off that clever flip? Well, it turns out there are two main ways to build it, and each one has its own pros and cons. Okay, the most common way, the one that's almost certainly in your charger, is called the bridge rectifier. It uses four little components called diodes. Just think of diodes as one-way streets for electricity. When the AC wave is positive, the current takes a path through one pair of these diodes. But when the wave flips negative, that path closes and a second pair of diodes open up, redirecting the current so it still flows through your device in the exact same direction. So clever.
The other design is a bit more old school. It only needs two diodes, which is nice. But here's the catch. It needs a special, more expensive transformer that has an extra wire coming out of the middle. Basically, the fancy transformer does half the work of splitting the AC wave, and then each of the two diodes handles one half, taking turns sending power out.
So at the end of the day, it's all a trade-off. The bridge design uses a standard, cheap transformer, but wastes a little more energy as heat. The center tap design is more efficient with the voltage, but it needs that bulky, expensive transformer. You can probably guess which one usually wins for modern tiny electronics where cost is everything. Yep, the bridge rectifier.
Okay, so we flipped the AC wave, we're using all the power, but we're not quite there yet. If you look at the output, it's still just a bunch of positive humps. It's all going in the right direction, but it's not that smooth, flat line of pure DC that our electronics are really hungry for. There's one last step. This bumpy output has a name. It's called pulsating DC. And here's a cool little fact. Because we're now using both halves of the AC wave, the frequency of these pulses is double the original. So that 60 Hz from your wall has now become 120 pulses per second. We've just got to fill in those valleys between the pulses.
And the hero of this final step is the capacitor. You can think of it like a tiny, super fast-acting battery. We place it right next to the device that needs power. As each DC pulse rises to its peak, the capacitor charges up, storing energy. Then, as the pulse starts to fall, the capacitor instantly discharges that stored energy, filling in the gap. The result? A much smoother, flatter DC voltage that's finally ready for your electronics. So, this little circuit, this clever dance between diodes and a capacitor, it isn't just some neat idea in a textbook. It is, and I mean this literally, everywhere. It's one of the true unsung heroes of our modern world.
Let's just start in your home. Every single charger and power brick you own has a full wave rectifier inside. Your computer's power supply? Yup. Your TV, your radio, even the little digital display on your microwave. You bet.
Step outside and you'll find them on the road. The alternator in your car uses one to keep the battery charged. The charger for an electric vehicle uses a massive high-power version to do the exact same job. Even electric trains depend on them.
And in the industrial world, oh yeah, they're absolutely indispensable. They provide the stable DC power needed for everything from arc welders and giant motors to critical, life-saving medical equipment and even the systems that connect solar panels to the grid.
So the next time you plug your phone in, just take a second to appreciate that little power brick. Because inside, a full wave rectifier is silently performing that invisible flip 120 times every single second, turning chaotic waves from the wall into the clean, stable power that runs your life. It really makes you wonder, right? What other invisible circuits are out there, quietly making everything possible?